So last time I was on this stage was just as we had just finished hydrogen. It was February of 2014, and everybody in the development community was panting heavily, as I recall. At that time, we were just trying to get a first release out. It was, something that was somewhat of an experimentation. So it's been a fun ride since then. We continue to make great progress. And what we're going to do in this session, Kelly kind of went a step back and talked about the industry and the open source's impact on it. We're going to do the opposite and actually talk more about how the sausage is made. First off, let me get a sense who works on OpenDaylight, either internal to your company or externally as part of the open source community. Raise your hand if you do something with OpenDaylight. So cool. I want to make this as interactive as possible. Because I have so many illustrious panelists, I don't have any mics to spread out, okay? So I want you to stand up, speak loudly, and I will repeat the question, but I want this to be driven by you, okay, and as questions. I want to talk about lithium, what we just got finished with, want to talk about beryllium, where we're going, and want to make sure that we answer your questions, all right? I want to start off by letting the panelists introduce themselves. Let's go ahead and start with Dan, since he sat next to me here. Dan, please start us off.
Sure. So my name is Daniel Farrell, dfarrell07 on IRC and everywhere else, if you want to find me and ask questions later. I'm a software engineer on Red Hat's SDN team, under Chris Wright on the R&D office. During the Helium release cycle, I did a lot of performance stuff with OpenDaylight, so it was kind of getting bootstrapped. I was a part of that bootstrapping process. In this last release cycle in Lithium, there was a lot of need from OpenFV to do some, to be able to support automated deployments of OpenDaylight. And so I've kind of taken a sidetrack to add a whole bunch of deployment and packaging tooling around OpenDaylight. So I built our RPM, our Ansible role, our Puppet module, our Vagrant Basebox, our Packer tools to build that, our Docker containers and images. So we kind of have a nice tool system there, ecosystem of tools there. In this next release cycle, I'll definitely be continuing both of those efforts, probably moving back towards performance a little bit more, but they mesh well in the context that we'll talk about soon with performance testing in real-world environments with OpenFV and such.
Very good. Brady?
Yes, Brady Johnson. I work at Ericsson. I work in the service function chaining project. I was the project lead in the Lithium release. Worked primarily in the OpenFlow plugin and starting now as the project lead for Beryllium. I also work in OpenFV service function chaining as a project lead there as well.
Very good. Ed?
So my name is Ed Warnicke. I write a little code here and there. So I think I'm a committer on controller, OpenFlow plugin, SFC. I've written a bunch of code for the OVSDB project. I just sort of go scurrying about doing whatever happens to be needful on that particular day.
Yes, I would say Ed was panting harder than anybody when we finished. Be a fair statement. Tony?
Hi, my name is Tony Tkacik. I'm working with the OpenDaylight since in the beginning. I was designing and architecturing, implementing the MD-SAL all over the time, and I'm the committer on the Yang tools and the controller project. And that's pretty much sum it.
And Colin.
I'm Colin Dixon. I'm the chair of the technical steering committee, which basically means that I get the responsibility of delivering things on time and no authority in order to actually make anybody do anything, which is a lot of fun. But I also spend a bunch of my time basically sort of being the complement to Ed, where if it's not code and it's broken, I'm probably the person who's responsible for trying to figure out how to fix it, whether it's documentation or release planning or keeping projects on track. And I spent a huge amount of my time trying to figure out how to learn what we did well and badly from previous releases and plan next releases. And so actually, if you're interested, you can go look at, my secret to this is I have a list of the things we got horribly wrong in the previous release at the bottom of the release plan. You can go find it and look at it if you want, if you search for Helium release plan. And then we try and fold it into the next release, so that way we don't make the same mistakes twice. That's really all that's my whole secret. So.
No, but it's been working really well. So Colin, I'm actually going to start off with a question for you. Can you share with us what you're most proud of? Given that you're the TSC chair, you've been leading us for the last year or so, what are you most proud of at this point with regard to the project? And as we kick off Beryllium, what do you see as the most important focus areas for improvement?
So the thing I'm the most proud of is that we took a little bit over 6 months, but basically a little bit over a 6-month plan with 40 projects and something like 500 developers, and we landed Lithium on time and tested. And nobody, and you said panting during hydrogen, and I'm not going to say that the last week of Lithium was fun, but nobody felt, I mean, and people can disagree, but I don't think anybody felt like they were dying, and people did feel like they were dying at the end of hydrogen and helium, because I was there. And so I think that just our ability to mature and get to the point where we got something well tested, out on time, according to schedule, mostly without too many hiccups, it's a small thing to be really proud of, but it's a huge step forward, and I'm really proud of our ability to do that. And beyond that, I mean, I think just, when I was, so I'm an academic by training. I have a PhD in distributed systems. So before I was involved in OpenDaylight, I did this thinking about what are the really hard problems in SDN, because, I was writing papers, and if you don't have an idea what the grand challenges are, you're going to be doing the wrong things. And sort of every one of the grand challenges I wrote down before I started OpenDaylight are things OpenDaylight is trying to tackle. These are things like application composition, distribution versus centralization. How do you get from here to there in terms of how do you actually deploy SDN in brownfields, and also how do you deal with sort of heterogeneous hardware and actually expose it in a reasonable way. And so I'm really proud, the hardest research problems in the world are problems that OpenDaylight is trying to grab, and we don't have solutions for all of them, but we're at least thinking about the right problems. I guess the second thing you asked is what's the biggest challenge going forward?
What do you want? As far as as you look at focus for improvements for Beryllium, what do you think's at the top of your list?
The two at the top of my list are clustering and documentation. Clustering, we have some really amazing stuff in the bottom end. So we have an implementation of the RAF distributed consensus algorithm. It's sort of the state-of-the-art consistent distributed consensus algorithm. And then we have, based on top of that, we use Akka to exchange messages. So we're using some state-of-the-art techniques, and they're really good at the really low-level mechanisms. But we have done a less stellar job of providing APIs that applications find easy to consume. And so one of the things that I think we really need to focus on is getting those APIs right, and then helping applications and learning from what they need in order to get that out there. And I think second is documentation. Just open source projects have a long history of having really terrible documentation. And I think we're better than most, but we don't disprove the theory. But I've personally put a huge amount of time into documentation in the Lithium cycle, and I think that's a place where we need to invest, and we're trying to figure out what the right way to do that is. But the best way to do that actually is, those of you that didn't raise your hand as working on OpenDaylight, go find the documentation, and if you can't find it, that's the first problem that we have. But it's on the downloads page. If you go to download OpenDaylight, it's right next to the zips, and try and get some things done with the getting started guide and things like that. And if there are problems, email us or file a bug and help us improve. I think getting end users and people that don't have their nose in the code is the only way we're going to make the documentation better.
Yeah, I will actually reiterate that a tad stronger. This is an unequivocal advertisement. If you have any interest at all in doing documentation with OpenDaylight, particularly as users, right? As you've heard a lot of users this morning talk about how they've been rolling things out and getting things moving. Often in open source projects, documentation gets significantly improved because as those new users come on and see how atrocious it is, they actually feel compelled to help us make it better. So let me advocate that we will be very welcoming for anybody who has any interest whatsoever in helping us in that endeavor, because it is one of the areas that we want to focus on inside of Beryllium. Tony, again, I'll mention Tony is the project technical leader for the controller, the core controller. So as we talk about 40 projects, at the center of those is the controller. So this is what Tony is to the project. In Lithium, we saw the finalization of the AD SAL. It's been deprecated in Lithium. It's now removed out of Beryllium. Everybody has moved on to the MD SAL, or we're just now completing that. Can you talk a little bit about work that you've done on the MD SAL in Lithium, what you're most proud of there in particular?
So the most work done on the MD SAL in Lithium was the performance improvements at various places. That's for the MD SAL non-clustered or clustered. In the clustering, there were a lot of effort put into actually making it default and to improve the performance in the cluster. So currently, for example, the clustered data store starts to overperform in some use cases the in-memory, which was present in the Helium. So the folks in the clustering team did a really nice effort for that. And I was mostly on improving the performance inside one node.
Very good, very good. Brady, I'm sorry. Well, I mean, I'm going to go to Brady. I was nicely going down the line, and then I skipped. Brady. Yes. So a lot of folks in the audience are interested in NFV. As the project tech lead for service function chaining, can you talk a little bit about the work that's gone into Lithium around service function chaining and the collaborative work that you did across with the group-based policy project as well to implement functionality for NFV inside of Lithium?
Absolutely. So in Lithium, that was the first release where we got service function chaining working. Thanks, Dad, for that too. So yeah, it was a good release. As you mentioned, we also integrated GBP with SFC in the release. And SFC works by itself. It can work standalone. It has its own classifier. It can do what you need to do, but it's somewhat limited, right? So adding GBP gave us a whole nother dimension with the classifier. It's a much more feature-rich classifier functionality. So it really nice combination having the two work together. And it was, I think, one of the first OpenDaylight collaboration sort of projects like that, where we were able to integrate the two together. So, and now that we have that working in Lithium, now we're looking forward to Beryllium. We want to keep that momentum going. One of the major things we're going to do with the OpenDaylight Lithium baseline, SFC baseline, is integrate that into the OpenFV platform, OpenFV SFC platform. So take what we have working in OpenDaylight with GBP and SFC and get that set up in an NFV environment. So that's really exciting. A lot of fun work there. Lots of interest, as you mentioned. In the Beryllium release for SFC, we're going to improve the GBP integration that we already have set up. We're going to add service chaining reclassification. So if you already have a service chain assigned to a particular user, depending on certain inputs or things that happen, you can reclassify that to a different service chain. It's a really interesting feature to have in. It allows us to integrate with DPI and stuff, and then we can, depending on what happens, the type of traffic, we can reclassify the different chains. We're going to implement hybrid service chaining as well, so have different types of switches. We can have open flow switches or NetFlow or whatever. Let's see, there's a lot of different things. Also, we're looking into integrating VPN with SFC. Some interesting work. I'm sure I'm forgetting some other things, but yeah, I think that's probably enough for now.
Excellent. No, thanks, Brady. Ed mentioned that he indeed is a contributor on a variety of projects as well as a committer on a variety of projects. It's relatively common if you are new to the group and you come in and you ask a question on some channel or someplace, it's very often Ed is the guy who's the first one to actually come back and try to hold your hand and walk you through whatever pain you're experiencing. He's been that way since the beginning of the project. Ed, what I want to ask you is, what do you find the most exciting and interesting about the Lithium release in particular? You, again, have been neck deep in getting the releases out from the beginning, from hydrogen through helium into lithium. What do you find to be the most exciting working in the environment and as part of the Lithium release?
So it gets to be kind of interesting because the thing I find most exciting is actually sort of an overlap between cultural maturity that we're starting to see and also technical issues. So one of the fundamental technical problems that we've been trying to deal with over time has been, how do you get applications to coexist? It's a relatively simple thing to write the one true monolithic application in the sky, right? You can see tons of examples of this. And it's not an unnatural instinct. But to really take advantage of what OpenDaylight has to offer and what really distinguishes OpenDaylight from previous attempts at doing controller technologies is that we're a platform which is designed to have multiple applications. And there are tricky bits about getting them to coexist when you get down to the level of things like flow tables and switches that are somewhat open problems. And people have approached them in a variety of ways, many of which have had some success but limited success. And what we saw emerge in Lithium and this is sort of the technical side of it, I'll talk about the cultural side in a moment, what we saw emerge in Lithium between the group-based policy project and the service function chaining project was sort of the first step towards us achieving that application coexistence cleanly in a way that naturally fell into the most successful meta pattern for doing so in all of human history, which is the Unix model. I mean, the Unix model basically says, do one thing well. So Brady's comment about, SFC does all this really cool SFC stuff, and it can do it all by itself. But rather than trying to be everything to everyone and be the whole world and doing SFC moderately and everything else poorly, they actually have a clean handoff between group-based policy and them. So again, you have people focusing on strong areas of competence and working out lightweight pass-offs between them in order to coexist. And that's a pattern I would really like to see us extend as we fill more gaps in sort of a stack or layer-based approach to coexistence of applications, particularly when you get down to the level of the flow table as we move into Beryllium. And that's sort of the technical view of what happened there. But the cultural view is actually also critically important for us because historically as a community, OpenDaylight's culture has been really quite lovely. I mean, historically, when you look at OpenDaylight, I could spend the entire session telling you stories of places where people helped each other, where people reached across projects to things that were not in their direct interest and lifted other people in the community up. And that's a part of our culture that I think we're all extremely proud of. But what's started to emerge now culturally is a situation where it's not just reaching across and helping someone up, it's figuring out how to collaborate together across projects to produce outcomes that are greater than the sum of their parts. And again, GPB and SFC is a good example of this. There's incredible power in what SFC does. There's incredible power in what GPB does, group-based policy. But when you bring policy and service functioning together, service function chaining together this way, it's much greater than the sum of its parts. And so I'm looking forward to seeing more pieces of that puzzle come in because the synergy gets even greater and it makes the community even healthier culturally.
Excellent, thanks. Dan, as we embarked onto Lithium, we went through some pretty significant transformations inside the integration project. Can you talk a little bit about that integration project, what it does, and how that evolved throughout the Lithium release process?
Sure, yeah. And I forgot to mention I'm a committer on the integration project and have been for a while, so that's why he's asking me about integration.
That helps.
Yeah, so the integration project is one of the sort of fundamental core projects of OpenDaylight that a lot of people end up touching because we host a lot of tests and we obviously build the distribution. So we interact with a huge portion of the community. One of the big changes, I think, about how we do that interaction in Lithium that Louis, whoever he is here, helped pilot is that we've done a good job, I think, of enabling projects to write their own integration test. And instead of the integration team specializing in that, and we kind of going around to all the projects and learning about their deep internal functionality, and then we try to hack together some integration tests to make all that work. We've done a lot better job of enabling diverse community members to show up into our repositories and send tests. I think we do a really good job of reviewing those and giving them feedback and teaching them about how to write robot and Python libraries and test code to get their functionality tested in our continuous integration environment. And that's been one of the biggest wins, I think. That cultural change was important, but one of the biggest wins is the sheer number of things that we've moved into CI, the sheer number of tests that we've moved into continuous integration. So a lot of that was performance. There was a huge push, I guess, at the beginning of Lithium. In Helium, there had been people working on performance, but there were a handful of us. At the beginning of Lithium, the community, as it sort of was plotting what it wanted to do in the next release cycle, it was a very clear goal that we wanted to formalize our efforts around performance. So the board came up with a name for it, S3P, scalability, security,
stability and
performance. But and that was part of it. But really, it was I think the board and the community were coming to the same decision at about the same time. So there's a ton of people that came into the integration team because of that sort of cultural realization. And now we have just tons of people working on performance things and scale things. And that number of things that we're working on in parallel, the number of types of performance testing that we're doing now is impressive. I think gives me a lot of confidence about OpenDaylight and our ability to measure those metrics.
Very good.
And it's all done in open source code in the tests, so you can go, none of it's like, it's not weird secret sauce. It's like code checked into the integration project where you can go download it, run it, test it on your own VMs, and it gets run every time we check things in. So the result is like, you can go see, are we lying to you or not about what our performance numbers are, and you can check if they match what you can do on your system. So and we're looking to improve a lot of that. And Daniel has been doing just amazing stuff in that space, as is the entire integration team. That's one of the, open source projects tend to be bad at testing. We have actually managed to avoid that. Documentation, we fell into the trap, but testing, we seem to have done better.
Yeah, and I'll at this point also give a plug into the OpenStack project as well, because we leverage and will continue to leverage their continuous integration testing tools as we continue to expand out our project. So this collaboration doesn't just occur within open source projects, but we are shamelessly leveraging everything we can find to help our environment.
And frankly, OpenFE is leveraging us.
As it should be.
Well put, yeah.
All right. So I'd like to open it up for questions, right? There's again, the cool thing about open source projects is we're transparent. So painful questions, fun questions, whatever it is you would like to hear from us, please let me know. Again, stand up, try to speak. Yes, sir.
So I have a question about the gentleman who spoke about cultural positives that came out of separating GDP and SFC work. I was wondering if you can give me some color on what you meant and what exactly to separate it.
Oh, so it's interesting. It's not that they were
So
separated.
I'm not sure that everybody, could you repeat
Apologies,
it? Or?
sir. Please repeat the question.
Okay, the question was, and I believe, correct me if I'm wrong, but Ed had mentioned the relationship between service function chaining and group-based policy, and how there was a separation of that of those different activities. How did that work, and basically, what was that culture, and how did it work? Mm-hmm. Did I capture that correctly?
What are the positives of that?
What are the positives of that culture?
Mm-hmm. The split that arose, and you said something about development community felt a lot more positive about this happening, and that does two things.
I have a comment when you finish too, but
I was going to cue
The underlying, and also what you meant by the cultural piece.
Okay, so both culturally and technologically, the separation and the collaboration that occurred between SFC and group-based policy. Yeah.
So first, I may have miscommunicated this. It's not that group-based policy and SSC were separated. It's that they had started doing and focusing and getting very good at the particular thing they were doing. And so one of the things that was very positive culturally about them collaborating in a way that those projects now work really nicely together was the fact that the natural instinct when you get to a point where you're, say, policy, you decide that you'd like to do service function chaining, or your service function chaining, you discover that you need a little bit more than what your classifiers give you. The natural human instinct when you're in a sort of a sub-community like that is to say, well, okay, we'll just try and do it ourselves. And that's very human, but often it's not the most productive choice you can make. And it's a little bit more mature culturally to sort of say, okay, there are these guys, I kind of know them in passing, let's see if we can work together with them and look at sort of maintaining those core centers of excellence in policy and service function chaining, while at the same time allowing sort of a broader community to spontaneously form among the two of them together. I think that's incredibly culturally healthy. It's how you actually build useful cultures from the ground up rather than top down. It's how you put yourself in a position where it's the knitting together of things that work well technically instead of sort of trying politically to make decisions ahead of the technology, which is coming from the top down. So I think that was very positive culturally. From my point of view, technically, again, it's learning from the most successful meta model technically in all of human history, which is the Unix model, saying, okay, let's have things that do their job well. Let's have very simple ways for them to talk to each other. And proceed forward in that manner. Now, I'd also like to throw this over to Brady, because he actually was ground zero for a lot of this. I was sort of doing my usual drive-by behavior around all of this, where I sort of zoom by, drop a few patches on your head, and disappear.
Yeah, so it was really actually an amazing experience. I really enjoyed it. Keith Burns played a major role in this. Thomas did as well. But one thing that was really interesting about how this integration worked, normally, well, okay, lots of times in these projects, right, each company kind of has, I'm going to work on this is my thing, this is what I'm going to do, and then everyone's kind of in their own little area. But it was amazing because okay, they came up with the idea, let's integrate these two together, how are we going to do that? Then we had people from Intel doing one part of the integration, myself from Ericsson, I was doing the OpenFlow part, Keith was doing another part, Thomas was doing a different part from Cisco and that. It was really interesting, really amazing to see people from different companies that, I mean, they kind of put their political things aside and said, okay, let's all work on this together, from different companies, different time zones. So I think that was really, really interesting, and to speak to the cultural part of it. You know.
Yeah. I mean, the other thing that was nice technically about the whole thing was that it allows you to fill in a really nice way some of the things that you kind of want. Like the example that comes to mind is there's a strong desire to have service function chaining be something you can do in concert with things that are deployed by OpenStack. So you deploy a VM with OpenStack, and you'd like to be able to use that VM in a service function chain that involves a broader space of things, not all of which are going to be VMs or even servers. Now, I mean, it would have been a huge amount of work for you guys to sort of cobble together some way to do that within SSC.
Yeah.
Because there's a lot of things semantically that go into the Neutron API that are just foreign concepts to SSC. It's just not in the scope of what you're doing. But on the other side, now you had group-based policy, which has been translating those into a broader policy that actually can get done. So group-based policy can take care of the stuff that you want to do there that SFC doesn't understand, and then get the handoff behavior to SFC in a way that like everything actually works. And it stands up, it works together, it does stuff, and it does things that have never been done before. I'm not aware of anything else that can do this end to end.
Yeah.
Yep, very good. I'll also just add that, you know, in the last presentation, Kelly had one slide that talked about, you know, the slower ramp of open source and the faster ramp, but the glide off of proprietary. And then he showed another slide that talked about the modularity of open source. And I actually personally find the two fit well together in the fact that, yeah, it often takes longer to get started because you want to build an open source platform that is modular, that is very easy for new people to come in and contribute to. And doing a modular structure allows for that. And what ends up happening is the different pieces of that modular thing that you're building out start to leveraging one another. And this is, again, one of the first concrete examples of that actually happening within OpenDaylight. Next question. Oh, really? Wait. Okay, yes, sir. Stand up and try to speak loudly.
Did you want me to summarize the question, or do you want to do that?
All right, yeah, please go ahead and repeat the question.
So the question was twofold. One of them was for clustering in Beryllium, are we focused on HA, so failover, or are we focused on scale-out performance? And the second question was, there was a persistence project in Lithium, and how does that tie into things? And so the persistence project is basically a project to provide database-like APIs, so sort of more row-based relational databases, and designed to run against things like HBase. So I'll take them one at a time. I think the short version is that we want to do both scale-out and HA, but I think it was, I'm trying to remember who stood up and said that prioritization is choosing what to not do. HA is more important. To us, at least right now. I mean, that's the feature which, at least I'm hearing everybody that is in the community and people that are actually trying to run this as products, what they need is they need HA and failover. They also need scale out, but they need HA and failover first. And I think we're gonna end up with both, but that's sort of the prioritization. Would you?
I would add actually that, yeah, HA is priority, but what we plan in the Beryllium is actually to do the work for the scale out also. Yeah. So, if everything's go right, by the end of the Beryllium, we will be able to also scale out the controller to much larger number.
So and then the second thing was around persistence, and I mean, I think that there is there's a recognition that there are different kinds of data the controller is collecting. There's sort of the MDSAL, which has sort of the running sort of immediate state and configuration of the controller. And then there's sort of telemetry and time series data. There's a time series data repository project also in Lithium. And that's it may turn out the MDSAL is perfectly suited to store 10 million entries of time series data for OpenFlow, but we certainly haven't designed it that way, at least not yet. Is it really?
Actually, MDSAL is designed also in a way that you are able to store a lot of data, and also we have some possibilities to do the compression.
So anyway, so there's, well, I think there's an open question. I mean, I think that the biggest reason why getting it out matters is mostly getting it into a format that other things are expecting, which it turns out like HBase is becoming basically, for better or for worse, one of the standard ways that you get things into an analytics pipeline. And so I think that it's actually, the persistence project to me is more interesting for its ability to export data to a format that other people can understand and feed through analytics pipelines and things like that than it is, strictly speaking, sort of as a way to store critical data for the controller. And that's just because of how it's integrated. But I think that that's the storing, archiving, and giving schemas to large amounts of historical telemetry and things like that, and then feeding into analytics and doing things like machine learning and artificial intelligence. And if you haven't seen Dave Meyer talk about that, please do. And he's around if you can find him. You should, if you get a chance, pick his brain about that kind of stuff.
Yeah. The other interesting thing that's fascinating to me about your question is it gets to sort of something that can be often very confusing when you're dealing with open source projects, when you're used to dealing with sort of more directed development models like you'll sometimes see in corporations, which is, it's very normal if you're running a software development shop as a company where you've got essentially a single hierarchy to say, okay, which is more important, A or B? We're going to put all the wood behind A. That's a very natural way of managing software projects. Open source projects do not work like this at all. And the reason is because if I'm running a software shop and I'm looking at A and B, I can take resources from B and put them on A. That's a doable thing because they do what you tell them to. As everyone here could attest, no one does what you tell them to in open source. And so when you're trying to make a choice between A and B, you can sort of do two things. One, you can try and be really compelling about how awesome it is that we should do A, which Colin does brilliantly. Or B, you can say you're not allowed to do B, right? And those are your two choices if you're trying to like nudge an open source project. And the problem is that when you say, no, you're not allowed to do B, or you try and discourage B, is those resources don't go work on A. They just leave. And so when someone says, okay, we're gonna do A or B, it's like, yes, we can get someone like Colin who's extraordinarily good at saying, yes, we should all do A, and that's productive. And I actually really agree with, as much fun as like big scalability is, that HA is, in my opinion, a more critical direction to start with. But I think Tony sort of got to the point of, we also expect to see a lot of amazing scalability things happen in Beryllium as well.
Yeah. That's actually something which, I mean, this is a really critical point, which is, you can convince something like 10 to 20% of the resources to work on the thing if you're persuasive that you think matters. And sort of, you end up with a ship kind of like OpenDaylight, which is just an epic amount of inertia. That is mostly going in the right direction, but you have no control over. And your goal is to try and take the 10 or 20% where it is that where the vision of, what's critically important, like HA, can sort of be directed. And the goal is to try and get that to line up with the 80% of the rest of the ship, which is doing exactly what it wants to do, and try and get it to sort of all move. And this is part of the reason why when Kelly started talking about like it accelerates slowly, but once it gets going, don't stand in its way. It takes time, but I think we're getting there. And so that's like, in every given release, we have a couple of things we're gonna work on. Like I said, documentation and clustering. And that's something where, that's where that 10 or 20% of resources, where like Tony and Moyes and Tom Pantelis and Luis and the OpenFlow guys and Anil Vishnoi have sort of all gotten together and said, okay, here's a set of people that believe in this. It's, something, it's probably not 10% of our development effort, but it's a non-trivial percent of our development effort in the people that I just named. Those are some really spectacular engineers. And they believe that's important, and they're gonna go do really cool stuff. And I'm gonna watch because I don't get time to code anymore. But it's gonna be awesome.
Yeah, I mean, that's actually one of the other things. If you're coming in from the outside, say you're someone in a company looking to do planning around your participation in fill-in-the-blank open source project, is it also becomes very natural to say, okay, great, let's see what people are talking about as the most important things and let's throw our weight behind that. And there's a lot of goodness in that, and I don't want to discourage that. But often, the coolest things are the things that emerge as you get moving. So if you were to sit down and look at planning, for example, for Lithium, so like the collaboration stuff that group-based policy and SSE did was nowhere on anyone's radar at all. That was an emergent thing. It ended up being one of the cooler things that sort of came together. So do always be aware that things shift a lot faster and more fluidly than you're accustomed to.
Yes, sir.
One of the things that I've heard in a couple of the briefings so far has been the question of security. A lot of people that I deal with, as an excuse for not adopting technology like this is that I don't know the supply chain, where this stuff comes from. So why should I trust it? How do you answer or address a customer who brings an attitude like that to the table?
So the question was basically security. How do you convince people that it's tolerable in a product like this? And I'm going to take product like this to mean open source and centralized sort of SDN as two different parts. Is that reasonable, or is that okay? So open source, let me just start off by saying that there are there are probably some. There are a vanishingly small number of credible people in the security community that think that open source is less secure than closed source software. Yes, there are bugs in open source software. Yes, there are things like Heartbleed. They do suck, but you find out about them in open source projects and fix them in open source projects faster. And this idea that with enough eyes all bugs are shallow isn't Linus's law is not bullshit. It really does fix problems, and you really do find things. And so open source in general, even if you talk to even if you go talk to the people for whom security is the most important thing in existence. Go talk to the NSA or any of the intelligence agencies. They are all based on open source security elements because that's what they actually trust and can understand and can build on. So that's sort of the first thing about security. The second thing is around sort of centralization, and that's something where versus decentralization and sort of what's the trade-offs there. And I spent some time talking to customers about this. Essentially, I think there's no clear win in sort of centralizing all the control of your network. On the one hand, you have one place where you can go and harden and work on things as opposed to 400 places. On the other hand, and so that lets you deal with security issues better, potentially have centralized policies for things. On the other hand, it's a very ripe target. And so I think in general it's a slight win, especially given that we're moving to software from firmware. And when we're doing Java software, there's model checking, there's all kinds of crazy cool tools. There's the person who heads up our security response process is a guy named David Jorm. He works for IIX, which is a company in Australia. They also make the Cloud Router project, which OpenDaylight is part of. And so he really knows his stuff. And we've done a whole lot of working on trying to do security audits and basically make sure we understand that. But I think the understanding of Java x86 software security is generally speaking going to outweigh the cost of it being a riper target. But it's not an obvious win, but I think it's also pretty clearly not an obvious loss. And then the last thing is just sort of OpenDaylight in particular. We actually have a security response process. There's a security at lists that if you go to OpenDaylight contacts, the email in order to send it to, I won't say it out loud because I'll probably get it wrong. I always forget whether it's security at OpenDaylight or security at lists.OpenDaylight. But so if you send an email there, we do handle security responses. You can look at the security responses we've handled in the past. In fact, a relatively recent major one, we were able to find a bug, fix the bug, test the patch, and ship the fix in 4 days. And I don't care who you are or either open source or proprietary, that's impressive. Like 4 days response time to getting a shipped patched copy up online is just we take it seriously. So does that, I spent a lot of the time at the beginning of the Lithium cycle dealing with this. Yeah.
All right, we have time for one more question. Yes, sir. And did you hear that well enough? Or
Not all of it.
Is this a question around conflict of applications? Right, so how to avoid conflicts of ships of the night type problem with REST?
Really quick
REST-based
question.
apps?
Are you sort of getting to specifically the problem of REST applications that live outside of the controller? Or and I just want to make sure we're not talking about the or as well, are you getting to the problem of people who are not sort of socially tied in tightly to the OpenDaylight community? Because there are two problems. The second one? Yeah. Okay, cool. Because the second one actually is a lot easier to answer. The way you do it is you actually try and design the systems that you're using in a manner that plans for that unexpected. And I'll give one really concrete example off the top, which is the way we designed the extensibility for our OpenFlow plugin allows what I sort of call sidewise extensions to OpenFlow, meaning that you could go into your basement and write an extension for our OpenFlow plugin and never touch a line of code of the OpenFlow plugin and bring your new matches and actions and things into the OpenFlow plugin and take that binary and give it to someone who's never talked to an OpenDaylight community person. They could load it, run it, and make it work, and you can actually get your work done. And that turned out to be quite a bit more work than building a model where you had to come and bring patches directly to the OpenFlow plugin to get your extensions. But it is profoundly better for everyone. And so when you look at things like the collaboration between group-based policy and service function chaining, one of the things sort of personally I've been thinking about is how do you look at a generalized way of having that kind of a stack with clean handoffs so that you can say, okay, I either A, want to bring an alternate implementation for a conceptual layer in that stack and still have it work with someone who's never actually heard of it directly, or B, I would like to introduce a new layer into that stack and have some way to tie into the existing layers. And that's a complicated problem. There are active discussions we're going to be having at a design summit about how to move in that direction. But I think that becomes important because part of being a truly open thing is not having to know Brady.
It's not such a bad thing.
I mean, it's not having to, if you've been in a position where you're dealing with a community or a project where you have to go in and you have to politic and you have to know people and you have to get your patches into that project in order to make progress, it can be really exhausting. And so the more you can make the entire regime open so that the benefits you're coming to participate in the community for really are, hey, there's a lot more we can do together, as opposed to I can't do it all what I need if I don't get everyone else to come along, that leads to a much healthier community. Yep. Did I even vaguely answer your question?
Very good. Well, we are out of time. It is time for lunch. Please join me in thanking our panelists for the discussion today. But I want this to be driven by you, okay, and as questions. I want to talk about Lithium, what we just got finished with, want to talk about Beryllium, where we're going, and want to make sure that we answer your questions. All right. I want to start off by letting the panelists introduce themselves. Let's go ahead and start with Dan, since he sat next to me here. Dan, please start us off.
Sure. So my name is Daniel Farrell, dfarrell07 on IRC and everywhere else, if you want to find me and ask questions later. I'm a software engineer on Red Hat's SDN team under Chris Wright on the R&D office. During the Helium release cycle, I did a lot of performance stuff with OpenDaylight, so it was kind of getting bootstrapped. I was a part of that bootstrapping process. In this last release cycle in Lithium, there was a lot of need from OpenFV to do some, to be able to support automated deployments of OpenDaylight. And so I've kind of taken a sidetrack to add a whole bunch of deployment and packaging tooling around OpenDaylight. So I built our RPM, our Ansible role, our Puppet module, our Vagrant Basebox, our Packer tools to build that, our Docker containers and images. So we kind of have a nice tool system there, ecosystem of tools there.
Twice. That's really all that's my whole secret. So.
No, but it's been working really well. So Colin, I'm actually going to start off with a question for you. Can you share with us what you're most proud of? Given that you're the TSC chair, you've been leading us for the last year or so, what are you most proud of at this point with regard to the project? And as we kick off Beryllium, what do you see as the most important focus areas for improvement?
So the thing I'm the most proud of is that we took a little bit over 6 months, but basically a little bit over a 6-month plan with 40 projects and something like 500 developers, and we landed Lithium on time and tested. And nobody, and you said panting during hydrogen, and I'm not going to say that the last week of lithium was fun, but nobody felt, I mean, and people can disagree, but I don't think anybody felt like they were dying. And people did feel like they were dying at the end of hydrogen and helium, because I was there. And so I think that just our ability to mature and get to the point where we got.
In this next release cycle, I'll definitely be continuing both of those efforts, probably moving back towards performance a little bit more, but they mesh well in the context that we'll talk about soon with performance testing in real-world environments with OPNFV and such.
Very good. Brady?
Yes, Brady Johnson. I work at Ericsson. I work in the service function chaining project. I was the project lead in the Lithium release. Worked primarily in the OpenFlow plugin and starting now as the project lead for Beryllium. I also work in OPNFV service function chaining as a project lead there as well.
Very good. Ed?
So my name is Ed Warnicke. I write a little code here and there. So I think I'm a committer on controller, OpenFlow plugin, SFC. I've written a bunch of code for the OVSDB project. I just sort of go scurrying about doing whatever happens to be needful on that particular day.
Yes, I would say Ed was panting harder than anybody when we finished. Be a fair statement. Tony?
Hi, my name is Tony Tkacik. I'm working with the OpenDaylight since the beginning. I was designing and architecturing, implementing the MD cell all over the time, and I'm the committer on the Yang tools and the controller project. And that's pretty much summarized.
And Colin?
I'm Colin Dixon. I'm the chair of the technical steering committee, which basically means that I get the responsibility of delivering things on time and no authority in order to actually make anybody do anything, which is a lot of fun. But I also spend a bunch of my time basically sort of being the complement to Ed, where if it's not code and it's broken, I'm probably the person who's responsible for trying to figure out how to fix it, whether it's documentation or release planning or keeping projects on track. And I spent a huge amount of my time trying to figure out how to learn what we did well and badly from previous releases and plan next releases. And so actually, if you're interested, you can go look at, my secret to this is I have a list of the things we got horribly wrong in the previous release at the bottom of the release plan. You can go find it and look at it if you want, if you search for Helium release plan. And then we try and fold it into the next release, so that way we don't make the same mistakes.
So last time I was on this stage was just as we had just finished hydrogen. It was February of 2014, and everybody in the development community was panting heavily, as I recall. At that time, we were just trying to get a first release out. It was, something that was somewhat of an experimentation. So it's been a fun ride since then. We continue to make great progress. And what we're going to do in this session, Kelly kind of went a step back and talked about the industry and the open source's impact on it. We're going to do the opposite and actually talk more about how the sausage is made. First off, let me get a sense who works on OpenDaylight, either internal to your company or externally as part of the open source community. Raise your hand if you do something with OpenDaylight. So cool. I want to make this as interactive as possible. Because I have so many illustrious panelists, I don't have any mics to spread out, okay? So I want you to stand up, speak loudly, and I will repeat the question.